Howdy, y'all. Today we're going to talk about these 6 argument patterns that are at the end of your reading of Chapter 3. If you recall, the deductive arguments are those that are intended to be valid, and validity is a function of the underlying structure or pattern that the argument follows. So what we're going to look at here are these 6 patterns, 4 of which turn out to be valid, and 2 of which are not valid, but are very similar in structure to a couple of the valid ones. And we're just going to kind of go through and talk about what they look like and things to sort of think about when you're looking at these kinds of arguments. So before we get into things, one of the first things I want to talk about is the conditional sentence. So with 5 of the 6 patterns here, at least one of the premises of the argument is a conditional. And a conditional is a type of sentence that kind of sets up a hypothetical situation. So you get in situations where if the sort of first part of the conditional happens, then the second part is going to happen. So you have this sort of if P then Q situation where the P's and the Q's are claims. So what you're doing here is the conditional is kind of making a claim out of a claim. It's making a new sentence out of 2 other sentences and putting them together with this logical connective, this if-then sentence. So you take any 2 claims or any 2 propositions, and you can turn that into an if-then sentence, a conditional. So like if today is Monday, then I'll go to the store, right? So today is Monday is a claim. I'll go to the store is another claim, and you put those together and you make this new sentence. So conditionals are typically written in one of 2 ways. So you either sort of write it if P then Q to focus in on sort of the P, or P only if Q, but either way it's the same sentence. The only difference is that what's going on here is that if you use sort of the first locution, you're trying to kind of focus on the P there a little bit. If you're using the second, you're focusing on the Q. And the reason that you might kind of shift there is because conditionals are used is oftentimes used to state sort of necessary or a sufficient condition. And so if you're kind of focusing on the P, so it's like if P then Q, what you're probably doing is sort of noting that the P, which we call the antecedent of the conditional, is a sufficient condition for the Q, which we call the consequent. So assuming that your sentence is actually true, then the P is a sufficient condition for Q. And what that means is that the P, if it obtains, will bring about Q. That's what sufficient condition means. Now, on the other hand, if you say P only if Q, you're focusing sort of on the consequent a little bit. You're drawing the reader's attention to the consequent, and we should note that the consequent is a necessary condition for the antecedent, which is to say that the antecedent cannot obtain unless the consequent obtains. So it's a necessary condition, but may not be sort of a sufficient condition. So it has to happen, but it may not be sort of enough for the thing to happen. So again, sufficient condition is enough for something else to happen. A necessary condition is something that has to happen. So this plays a lot in our reasoning, thinking in terms of necessary and sufficient conditions, and so it's not a surprise that a lot of our arguments contain conditional sentences. Okay, so let's get into some patterns here. These first 5 patterns are all going to have a conditional in them. And the first valid pattern that we're going to consider is something called modus ponens in Latin, which just translates to the method of affirming, or just affirming the antecedent. So this is a valid pattern, and what we say, or the way that it kind of works, the pattern is it starts with a conditional, so you're going to have an if P then Q. And this is sort of one of these deals where the P is what's sort of important here, right? So P, if this conditional is true, then P really is a sufficient condition for a Q. And so if you have P, so these, let's say these are our 2 premises, right? If P, then Q is a premise, and then P is a premise, then you're going to be able to conclude Q, that if these 2 premises are true, this conclusion, Q, would have to be true. And I should note here, I don't know if you've seen the 3-dot image before, but 3 dots just means therefore. It's a mathematical conclusion indicator. So yeah, so whatever you have for P's and Q's, and remember, your P's and Q's are claims, they're statements with truth value, but whatever you have for P's and Q's, if you plug them into this sort of pattern, and that ends up making sort of true premises, then you're always going to get a true conclusion. So it doesn't matter what the P's and Q's are, but if those premises turn out to be true, and again, they may not be, but if they turn out to be true, then the conclusion will always be true, right? So this is a valid pattern. This always works. So here's an example, right? So I'm replacing P's and Q's with a number is even, it's divisible by 2. So I have if a number is even, then it's divisible by 2. 4 is even, therefore 4 is divisible by 2. So 4 is even or a number as even is our P. A number or 4 is divisible by 2 is the Q. Plug that all in, and you have the modus ponens pattern. And if those premises are true, the conclusion has to be true. Here's another one. If you live in the Midwest, then if you live in Wisconsin, then you live in the Midwest. Tim lives in Wisconsin, therefore Tim lives in the Midwest. Again, same pattern, different words, but if the premises are true, the conclusion has to be true. And finally, here's a little more philosophically interesting argument. If nature exhibits complexity, then nature was designed, so if P then Q, nature exhibits complexity, therefore nature was designed. This is kind of a famous argument called the design argument. It's one of the multitude of arguments for the existence of God. So again, if both of those premises are true, then the conclusion has to be true. So wouldn't that be nice if both of those premises were in fact true, because then you would know that God exists. Okay, so just before we move to the next pattern, just kind of want to mention that modus ponens is a valid pattern, but I want to remind you that this doesn't mean that the argument is sound, right? In order to be sound, and in fact, for any of these patterns, you have to sort of keep this in mind. But for the argument to be sound, it also has to have true premises. So it's entirely possible that the premises in this in your argument are false, right? So even though the pattern is valid, you could have a false premise. So here's just sort of an example of an argument that has a false premise in it. So in this case, it's the if-then, right? It's the conditional that is false. So false conditional, it says if the number is odd, then it's divisible by 2, which is false. But nevertheless, we're in that same kind of pattern. 3 is odd, therefore 3 is divisible by 2. So one of these premises is false, so the argument's not going to be sound, but it is still valid. The pattern is such that if the premises were true, the conclusion would have to be true. Okay, the next pattern that we're going to talk about is an invalid pattern. So what this means is this isn't going to work. So an invalid argument is such that even if the premises are true, it's still possible that the conclusion is false. So you don't have the guarantee of truth like you have with valid arguments. So this one, affirming the consequent, is like affirming the antecedent, except things have been sort of flipped around. So the tricky thing about this is that it's very similar to affirming the antecedent, so it's important to recognize what's different between the valid form and the invalid form. So first of all, just like affirming the antecedent, you have a conditional, if P then Q, but now instead of P as a premise, you have Q as the premise. So in the previous pattern, Q was the conclusion, but now Q is a premise. And then the conclusion now is P. So when you flip the P and Q like this, you move from a valid form to an invalid form. So this doesn't work. Remember, Q is a necessary condition for something, not a sufficient condition. So just because Q obtains is not going to guarantee you that P obtains. So here's an example. If one lives in the Midwest, if one lives in Wisconsin, then one lives in the Midwest. My mother lives in the Midwest, therefore my mother lives in Wisconsin. So it's entirely possible that this conclusion is false, even though both of these premises are in fact true. In fact, my mother does not live in Wisconsin, but she does live in the Midwest. She lives in Illinois. So both of these premises are true, and the conclusion is false. So it's clear that this pattern is invalid as a result, right? It's possible for all the premises to be true and the conclusion false. Here's another example, same kind of deal. If the animal is a cat, then it's a mammal. Lista is a mammal, therefore Lista is a cat. Lista can be all kinds of different mammals here, right? Lista could be a cow or a dolphin or a llama, all kinds of non-cat things here, such that both of the premises would be true, but the conclusion is still false, right? So again, an invalid form. And, just one more example just to round things out here. If the sun explodes, then we won't have class. We didn't have class, therefore the sun exploded. Very easy for us to not have class without the sun exploding. So true premises and possibly sort of false conclusion. So before moving on, I just kind of want to mention that one of the ways to demonstrate that an argument is invalid, or any pattern that you think is invalid, is just to come up with a counterexample. Come up with a substitution instance that gives you sort of obviously true premises and an obviously false conclusion. If we look back to this Wisconsin one, I think this one's pretty obvious, at least from my perspective, that both of the premises are true. That if you live in Wisconsin, you live in the Midwest. That's true. Wisconsin is a Midwestern state. My mother lives in the Midwest. She lives in Illinois, so that is also a Midwestern state. And so both of those premises are true, but the conclusion is false, right? My mother does not live in Wisconsin. So it's a counterexample, right? It shows that it's possible for the premises to be true and the conclusion false, and you really just need one, right? You just need to show that it's possible to show that you don't have the guarantee. All right, moving on. Let's talk about another valid form here, modus tollens. So again, here's a situation where you have an argument that has a conditional in it, but instead of affirming one of the parts of the conditionals, we're going to deny it. So we got our P's and Q's. So instead of saying that P is true as a premise or Q is true as a premise, we're going to say that P is false or Q is false. And in this case, for the valid form, you have to say that Q is false or not Q. So again, bear in mind that Q is a sufficient condition. Q is a necessary condition. So if the necessary condition doesn't obtain, then you can conclude that the antecedent isn't going to be true, right? So this form of reasoning is valid. So if you have a true conditional and it's true that not Q, right? So it's false at Q, then it's going to be false at P or not P. So here we go. Here's another live in someplace type of argument, right? So if you live in San Francisco, or I should say you live in San Francisco only if you live in California. So using the only if here to get your attention on the Q here. But you don't live in California. So that's the denial there, right? So the opposite of you live in California is you don't live in California. And you conclude from that not P, which is you don't live in San Francisco. So again, we're denying the consequent here, and that will get you the denial of the antecedent. So this works. Here's another one similar to the numbers one I had before. If a number is even, then it's divisible by 2. 3 is not divisible by 2, therefore 3 is not even. Again, that works. If both of those premises are true, and it is, in this case, then the conclusion has to be true. And then finally, here's a more philosophically interesting one. This is known as the argument from evil. If God existed, then there would be no unnecessary suffering, but there is unnecessary suffering, therefore God does not exist. Again, kind of follows this pattern that you get not P from not Q, right? So the Q is, there would be no unnecessary suffering. Not Q would be, it's not the case that there's no unnecessary suffering, or by the rule of double negation, it's just that there is unnecessary suffering. And so you get God does not exist. Just kind of want to point out here that, remember, there's sort of two locutions for conditionals, right? The if P then Q, and P only if Q. So just bear in mind that they're both the same sentence. So even if you're not sort of highlighting the necessary condition or the sufficient condition, it doesn't really matter which sentence you use. You can use if P then Q, you can use P only if Q. From a logical point of view, they both mean the same thing. So it really doesn't matter. Okay, so I'm going to move on then to the second and final invalid form, which is the form that looks kind of like modus tollens. So modus tollens is valid, but this one isn't. Modus tollens is the method of denying the consequence, which works, but denying the antecedent doesn't work. So this is an invalid form. You start off with the conditional, right, the antecedent and the consequence. And if you say, or if you find out that the antecedent isn't true, and you try to conclude that the consequent isn't true, you're not going to have that guarantee, right? So truth is not guaranteed in this case. So here's an example. If I lived in Milwaukee, then I would live in Wisconsin. That's true. I don't live in Milwaukee. That's also true. Does it follow that I don't live in Wisconsin? No, it's not necessarily, right? I mean, I might not live in Wisconsin, but it's entirely possible that I do live in Wisconsin. In fact, Tim Hansel, does live in Wisconsin, right? I live in Madison, and so both of the premises are true. but the conclusion is still false. Here's another kind of a sillier example. If the sun explodes, we won't have class. That's true, right? Because we'll all be dead. The second premise is the sun will not explode. That's probably true, at least not within our lifetimes. And so does it follow from that that we will have class? Which is the double negative here, right? It's not the case that we won't have class. Not necessarily, right? That we may not have class for some other reason, right? So there's all kinds of sufficient conditions out there that could bring about the ending of class, not just the sun exploding. So this line of reasoning won't work. And then finally, here's just a little math one. If the number is even, then it's divisible by 2. That is true. And then here's another, that 3 is not even. That's true. And then the conclusion here is therefore 3 is not divisible by 2. Well, that's actually true. But it's possible that it's false, and that sounds kind of weird. So I threw this in here just to kind of screw with you a little bit, but what we're trying to show with this is that sometimes it's not really obvious that the reasoning kind of fails because everything is true, right? Your premises are true and your conclusion is true. But what we say here is that if it is true, it's not because those premises are true, right? Those premises, this pattern, does not guarantee truth, right? You might end up with something true, but it's kind of by accident when that happens. So keep that in mind, that when you kind of look at these things, it's not just a matter of looking at the premises and the conclusion and seeing that they're true, right? It's a question of the logic of what follows from these premises. All right, I want to end just to draw your attention here to the double negation stuff that's happened a couple times. So this happens a lot, that sometimes our P's and Q's are themselves negations, right? So we won't have class, or I won't go to the store, or so on and so forth. And so if you're going to negate that, right, if you're going to say not the case that not something, then that negations cancel out, right? So this is something that a lot of people already know, but I just wanted to sort of make mention of it, just in case is confusing to some people. All right, so our fifth pattern here is another valid pattern. So we're all done with the invalid patterns. These last two are going to be valid. So one thing about this is that it's a little bit different from the first four here in that everything is a conditional, or sometimes called a hypothetical. So we have hypothetical syllogism. So it's an argument that's made up entirely of hypotheticals, conditionals, and it's sometimes called a chain argument. But nevertheless, as I mentioned, this is a valid form, but the way that it works is that you have a premise, a conditional, if P then Q, but then you have another conditional that kind of chains or links to that first premise. So if you'll note, the consequent of the first premise is the antecedent of the second premise. So you have if P then Q, and then if Q then R. So the end of the first premise is the beginning of the second premise. So it turns out with hypotheticals or conditionals, if you do that, then you can conclude that if the first thing, then the last thing. So the Q kind of falls away, and you're left with the first and the last bit of the chain. So here's an example of that. If I live in Milwaukee, then I live in Wisconsin. If I live in Wisconsin, then I live in the Midwest. Therefore, if I live in Milwaukee, I live in the Midwest. It follows that pattern, and it's valid. Here's kind of a silly one, but again, this follows the pattern. If a rainbow appears, then trouble's on the way. If trouble is on the way, then evil is winning. Therefore, if a rainbow appears, then evil is winning. Same kind of deal. Fits the pattern's valid. So if the premises are true, the conclusion has to be true. And then finally, if I fail this course, I will lose my scholarship. If I lose my scholarship, I will have to withdraw. Therefore, if I fail this course, I will have to withdraw. Fits the pattern. It's a valid pattern. So if the premises are true, the conclusion has to be true. I wanted to mention about chain arguments that what's kind of neat about these arguments is that you can add links to the chain as many as you want, sort of ad infinitum. That as long as the links kind of match up, you'll be in a situation where you still have a valid argument. So I have an example here of a 5-premise argument where the conditionals are all kind of matched up. So I have if p then q, if q then r, so that's just like the 2-premise one, but I just sort of keep going. So if r then s, if s then t, if t then u. And I sort of end it there. So all those chains sort of link up, but I shouldn't say but all the chains link up, and as a result, you can conclude that if the first thing, then the last thing. And again, this is about the logic. So all of those premises actually have to be true, and the more premises that you add, the more opportunity you present for actually having a false premise. But if they're all true, the conclusion will be true. So the argument is still valid, despite the fact that you have a lot more going on. Okay, so that brings us to the last of the patterns, and the thing to note about this pattern is it doesn't have a conditional in it. So this is called a disjunctive syllogism. A disjunction is a different kind of sentence from a conditional. So conditionals are if-then sentences. Disjunctions are either-or sentences. So this is disjunctive syllogism, sometimes called argument by elimination. It'll probably look kind of familiar to people because people reason this way fairly often. So this is a valid form. Remember that everything is valid except for the 2 that we discussed, or at least out of the 6, 4 are valid and 2 are not valid. So this one's valid, but you don't have a conditional, right? So that's the real defining feature here, that it's an either-or instead of an if-then. So either P or Q, or either P or Q, however you say it. And then we're going to argue by elimination. So if we have not P or not Q, depending on which thing sort of gets eliminated, then you'll get to infer the other thing, right? So if you have not Q, if you have not P, you're going to get Q. If you have not Q, then you're going to have P. So just argument by elimination. You have 2 options. One of them has to be true. So if you know one isn't true, then the other one has to be true. So here's a pretty straightforward example. Imagine the Cubs and the Brewers are playing. So you could say, well, either the Cubs or the Brewers won the game. And if you know that the Cubs didn't win, you can infer that the Brewers won. So one of those 2 teams had to win. And if you know that one didn't, then the other did. It's either Monday or I'm losing my mind. It's not Monday, therefore I'm losing my mind. If those are the only 2 options, and you eliminate one, you have to conclude the other. That's how validity works. And then finally, this sewing machine is either a priceless antique or it's useless junk. Those are my 2 options. It's certainly not junk, therefore it's a priceless antique. Again, if both of those premises are true, the conclusion has to be true, right? Bear in mind that the premises may turn out to be false, but we're not talking about that. We're talking about validity. And so what we say is that if both of the premises are true, the conclusion has to be true. All right, well, I just wanted to say one more thing. This is another argument where you can kind of make it a little bit more complicated, and you can sort of add to this pattern and maintain validity. But the trick here is that if you're going to do an argument by elimination and you have kind of more than sort of two options, then you need to eliminate all but one in order for this to work. So this is an argument form that can get sort of very complicated, but you just have to remember, just keep in mind that once you've enumerated all the options, you need to eliminate everything that isn't true to get down to one. So I have here a pattern with four options instead of just instead of just two. So I've got P or Q or R or S. And if I want to conclude P, which in this case I do, right, I have P as the conclusion, then I have to eliminate Q, and I have to eliminate R, and I have to eliminate S. So you need not Q, you need not R, you need not S in order to do that. So it's still valid. It's still the case that if the premises are true, the conclusion has to be true, but it's a little bit more complicated, and thus can get into sort of problem or into trouble in the sense that there's just more opportunities for a premise or two to be false. So again, the argument's sort of valid, but there's going to be some concern about whether or not the argument is sound, right? You need validity and true premises for the argument to be sound. All right, well, that's it for the overview. Hopefully this will make a little bit more sense for the exercises, and bear in mind that going forward, we're going to see some of this stuff again. We're gonna revisit conditionals and disjunctions and negations and all that stuff later on in chapter 6. So the more quickly you sort of get a handle on these patterns, so the better off you're going to be.